Hello everyone. So in today's video, we're going to answer two multiple choice questions from the AQA Paper 2 exam. And this exam was the 2021 exam. So this was 2021 Paper 2 from AQA. So obviously you have your Paper 2 exam next week. If you're watching this in 2023, you've got Paper 2 on the 13th of June 2023. But of course, if you're watching this in future years, then this is a good video to watch because it's just some more past paper practice. So you can see how I answer these two mechanics past paper questions. So in the AQA syllabus, paper 2 is half pure, half mechanics. If you do edXL, for example, paper 2 is actually all pure. But regardless, it's good to, regardless of your exam board, it's good to watch this video because we're going to do some mechanics practice. So if you are looking for some mechanics practice, then do watch this video. So question 11, so section B, mechanics, question 11. Let's look at this one here. So a particle's displacement r meters with respect to time at t seconds is defined by the equation position is equal to 3 times e to the power 0.5 t. So we want to find the expression of the velocity. Circle the correct answer. So remember that position, so to go from position to velocity, you differentiate with respect to time. So why is that? Well, speed is the rate of change of position. That's what the definition of speed is. So the rate of change is just dr by dt. So you want to differentiate this formula for r, the position. So when we differentiate the r, when we differentiate this, so you've got 3 and then times by e to the power 0.5 t. So remember how we differentiate these exponential functions. So this 3 there is just a constant, so that remains the same. And then differentiating e to the power of something, you differentiate that power, so this 0.5 t with respect to t, that gives you 0.5. And then you multiply the entire function by the 0.5. So it's kind of just using the chain rule essentially. So you're going to do differentiate the power 0.5 t, that gives you 0.5. So 0.5 times by 3 times e to the power is 0.5 t. So half of 3 is 1.5. So you're going to get 1.5 times e to the power 0.5 t. That's going to be your velocity because that's your dr by dt. And that's our first option there. So that's going to be the first question done. That's our first one. So question 11, section B, AQA 2021. That's our answer there for the velocity there. Now let's go down to the next question, question 12. So I'm going to have to rub out this this writing here just because when I use Zoom, the writing follows me down with the AQA papers because the AQA website doesn't allow you to actually edit the exam papers, so I'm gonna have to rub that out, unfortunately. But yeah, this answer there was that one. The next one, question task, we've got a particle which has got a speed of 6 meters per second, and it's in a direction relative to the unit vectors I and j. So you got a speed of 6 going in this direction. The velocity of the particle can be expressed as v1, v2. So you've got a v1, which is your component in this direction. So your v1 is in that direction, and then your v2 would be your vertical velocity, well, your vertical speed in the vertical component of your velocity. So we want to find v2. Okay, so I mean, we've basically got like a right angle triangle here. I mean, you can kind of imagine this to be like a right angle triangle. You've got a hypotenuse speed of 6. We want to find v2, which is our opposite, so our vertical component. So opposite hypotenuse, that's sine. So this v2 must be, so remember, sine of theta is opposite over hypotenuse. So opposite is hypotenuse times sine theta. So this is going to be 6 times sine 30 degrees. And that's going to be our second option. So that one there. So our v2 is going to be 6 sine 30. So that was just a brief video today on how we answer those two multiple choice questions to prepare for your mechanics. So if you're AQA, your paper 2 is coming up next, and if you're edXL, your paper 3 mechanics will be coming up the week after next. So yeah, hopefully that was helpful. Just go for a couple of multiple choice questions on this paper here.